Welcome back. So far, to ensure our code has been working, we've been restarting our server, playing around with our front end, and making requests through Postman to test, for example, the validation on our endpoints. This works fine to get a general feel for how things are working, but as projects get more complex and there's more possible inputs and different endpoints, it's worth automating our tests for our APIs. If we search for API tests in our trusty Google image search, we can quickly get an idea for where API tests fit in the overall testing world. We can see this pyramid that has unit tests at the base, API tests above, and then automated UI tests right at the top, below, of course, the user who actually uses the application. And this is a common theme regardless of where we look. When we talk about these API layer tests, we're not talking about writing unit tests, which are the most often talked about form of automated tests, where you test a piece of code in isolation. For example, testing a module to make sure that a function that adds two numbers returns that indeed 5 plus 5 is equal to 10. Testing our functions in isolation would be a unit test. And we're also not talking about end-to-end UI tests, which would test your application by interacting with the front end and making requests against your API based on what that test clicks on in your user interface. All right, enough about what we're not talking about. What we will be talking about, what's important for our Node servers and APIs, is API tests, where we test the request coming in, going through all of our middleware, being processed by our request handler, and being sent back as a response. API tests like this are sometimes called integration tests because they test how many different units or components of your project work when connected all together into an API, into one endpoint, for example. Let's jump in and find out exactly how we can write API tests in Node. I'll see you soon. Welcome back. What do we use to test our APIs in Node? Testing in Node involves a few different tools being used all together. We have our test runner, which is what finds all of the tests in your project, runs through them, and gives you the results. We have what's called the test fixtures, where a fixture is just how your tests are set up and organized by module and by the individual test, where each test fixture can run in its own environment with its own sets of variables and data. We also have assertions, which are basically functions that allow us to check, for example, that we expect 5 plus 5 to be equal to the number 10. That's an assertion. And finally, we have mocking. For example, if we have a database and hundreds of tests that create, update, and delete data in that database, well, in that situation, we probably don't want the data from each test to stick around. to affect the real-life data in our database. So what we can do is mock our database where a create operation won't actually affect our data. Or maybe it just affects the data temporarily within that test fixture. Mocks are what allow us to replace or remove certain functionality when we run our tests. In the early days of Node, it was common to have to use different packages for each of these tasks. And each Node project would use a slightly different combination of each of these packages. The good news is that we now have one tool that is extremely widely used and includes all of these aspects in one package. We have Jest. Jest is an NPM package. It works on both the front end and the back end. And many other testing frameworks actually use Jest under the hood. If you understand Jest, you'll understand testing with any framework, and in fact, even in other programming languages. These same concepts carry over to all types of development. We can add Jest to our NASA project in our terminal by first going into our server directory, because we'll be testing our server, and npm installing Jest, this time as a development dependency, by passing in --save-dev. It's a development dependency because we test our code during development. We don't actually need our tests when we run our application in production. All right, this is taking a while. Jest is a fairly large library, so let's skip ahead. With Jest installed in our server's package.json, we can now finally add this test script that hasn't been specified since we started our project. We can set npm test to run Jest by just typing Jest. When we run Jest in this way, it goes through our project folder, finding any tests and running them. We're in our server folder, so we can try npm test, and Jest executes. Let me make this a little bit bigger. For now, it's failing because we haven't written any tests. But here it reports over which files it checked and the results of any tests that we've written. There's two main ways that Node projects organize their tests. In the first approach, we can create a folder at the root of our project, specifically the server project, and we call it __ tests. This folder will now contain all of the tests for all of the code in our application, in our server. And the alternate way is to write your tests alongside any modules that they're testing. For example, say we wanted to test our launches router. We could create a new test file in our launches folder and call it either launches.test.js or launches.spec.js. Jest will recognize both of these formats. As we can see in this test match field here, where Jest is matching the tests folder and the spec or test.js files in your project, and running those files as Jest tests. which approach do you think is better? That's right. If we follow our reasoning from earlier, where it's better to have related code live side by side, then it makes sense to keep our tests alongside the code that they're testing. So let's create a launches.test.js that will include tests for our launches endpoints. And we can delete this __ tests folder. Let's write some tests. If you've done any kind of testing in JavaScript in the past, this might be review, because Jest follows the same patterns that other testing frameworks use. But we'll be talking about things in the context of writing API tests, which you might be less familiar with. We can create a test fixture with different test cases by using this describe function and passing in a description for our group of tests. So say we have one group where we test getting the launches endpoint, and we have one test or group of tests where we test creating new launches with the post endpoint. Our tests are defined in this callback that we pass into the describe function, which can call this test function that defines each of our test cases. So for example, it should respond with 200 success. That's the name of our test, and then we can pass in a callback function into test with our actual test code. For example, we have a response that we set to whatever our API responds with. For now, we haven't made our request, so let's just hard-code it to 200 as a starting point. And then we use these assertions that say we expect the response dot to be 200. And we should check our error cases as well. So let's go to the post endpoint. We'll define our set of tests here and say that the first test, well, it should respond with 200 success. We'll define it very shortly. But we also want to check that it should catch, what was it that our launches controller did? We had error handling that validated we have all of our required properties and that we pass in a valid date. So we should probably check for these cases in our test. Our endpoint should catch missing required properties. And it should also catch invalid dates. That's a good set of tests for us to start with. We could be as thorough as we need in testing our APIs here. But you might be asking, where is this describe function coming from? Or test, or expect? These aren't built-in JavaScript functions. It's Jest that knows where to find these functions in its own modules when you run the Jest command. This is a little convenience feature that the Jest test runner gives us. So now if we run npm test, I'll clear our console, and we can see that Jest is finding our test file, and oops, our test suite failed to run because we misspelled describe. Let's fix that. Describe, and let's try again. npm test. We're getting a test report from Jest that each of our test cases is passing because we're not really testing much. We're getting a breakdown of each test case in each test group, as well as the time it took for all of our tests to run. Very nice. And Jest also lets us watch for changes in all of the code that's related to each of our tests. And it will rerun those tests if we run it with the watch flag. So we can create another script for us called test-watch, which runs jest --watch. With this command, our launches test will get rerun anytime our launches route gets updated. This allows us to get instant feedback on whether our tests are passing or failing, which makes it easier to maintain our code and make sure that we're not breaking things. If you'd like to read up more about the various options for Jest, it has this excellent site with documentation, as well as an API reference with each of the functions that Jest makes available globally. Notice, for example, the describe function, which creates a block of related tests. And we have this excellent example for how it can be used. This is an extremely useful reference, so I suggest you bookmark it if you're going to be writing tests for your code. So what do we have? In our root package.json, at the root of our project, if we run npm test, it will run our server tests as well as any client tests that we put in. And we can actually simplify this. We don't need to call npm run on the test command because it's so common. So npm lets us just do npm test directly. All right, so how do we make our tests actually make requests against our API and check for something useful? We'll learn one common approach in the next video. I'm looking forward to it, so I'll see you soon. Welcome back. We've written some test cases for our API, but they're not very useful. Most of what we've talked about so far applies to API tests, but also to unit tests and any other kinds of tests. So let's get on with it. How do we write our API tests? We need to make requests against our API and test the response. For this, I like using the supertest library. Supertest allows us to make requests against our Node HTTP servers. And it also provides some convenient assertions on top of what Jest provides for us. These assertions are specific to HTTP requests and responses. Just like with Jest, in our terminal, we'll npm install supertest as a development dependency in our server project. We can now require supertest inside each of our test files. And we'll call supertest request when we use it, because supertest will be the tool that makes requests against our API. So require supertest. And now, how would we test our GET request? Well, we call this request function that's made available through supertest. So we'll set our response to be equal to request, and we need to pass something into this request. Supertest expects this app object, which it so happens is the app that's exported from our app.js. It's that Express server, or that Node HTTP server, the one with the listen function, which means that in our launches test.js, we'll require our application. We'll say app equals require, and app.js is one level up out of our launches folder, and then another level up out of routes. So .. /.. app.js. And that's the object we can pass to our supertest function. See how everything worked out with the way we organized our Express server into this app.js file with all of our middleware, and the server.js file, which takes that app and starts the server using the listen function. Breaking things out pays off as we start adding more complexity to our project. So how do we make requests? Well, we just call the corresponding method on the result of this request call. So if we want to make a GET request, we say .get and then /launches. And supertest knows that we're making a request to /launches on the server that we pass in. And the result of this call can be awaited using the await keyword, which means that we make our callback here async. You might see some old supertest code that uses callbacks and promises everywhere, but the best way today is using the async await syntax. It's much easier to follow compared to the approach that uses callbacks. And now we can expect our response, this time specifically saying response.statuscode, to be 200. Let's see if we're actually testing our API. We'll do npm test in our server folder. And check it out. Our get test here took 34 milliseconds, and our assertion passed. That's why we're getting this green check mark. Now, I want to take just a moment to show that supertest isn't magic. I know it can seem that way sometimes, and it did when I first started using it. But all this request function from supertest is doing is taking the app object you pass it, calling the listen function on that object, and then it allows you to make requests directly against the resulting HTTP server. Just like the browser's fetch function or the Axios library. It's really just a convenience tool, but it's one that's widely used. All right, so we could keep using these jest assertion statements to check the different properties like status code on our response. But when it comes to things specific to HTTP, supertest gives us its own convenient assertions. What we can do is chain these functions, so say request app.get launches, and then chain .expect, passing in the status code that we expect to come back, so 200. That's much easier than calling all of this. And similarly, we could call .expect and check the headers. So if we pass in a string like content-type, we can match that header to some string, or to a regular expression using JavaScript's regular expression syntax. For example, saying /JSON/, which will match the content type as long as it contains the word JSON. Let's see if this works. This time, let's run npm run test-watch, and we'll build out the rest of the tests in our file for our launches while getting feedback instantly from Jest when we run it in watch mode. So there's our tests passing. Looking good. We'll keep going in the next video. I'll see you soon. Welcome back. Let's get back into it. The get method was pretty simple, but what about testing post requests? We'll start off similarly by making our callback here async and setting the response equal to await request, passing in the app object with all of our Express middleware, and then we'll chain, this time not get, but .post on the launches collection. So that's a post request. To send some data, we can call this .send function, which takes in an object that will be passed in as JSON. So what were our required launch properties again? We set the mission, say that's the USS Enterprise. We needed to set the rocket, which can be something like NCC 1701-D. And we need a target. That's our exoplanet. So target will be Kepler-186f. And finally, a launch date. So we'll set it to Isaac Newton's birthday of January 4th, and we'll say it's 2028. Now, just like above, we can check the headers and the response status code. So we'll .chain. Just like above, the content type must be JSON, and the status code this time isn't 200, but 201 created. So we should actually rename our test case here that a post to /launch should respond with a 201 created. Let's check our terminal to make sure that things are passing. Looks good. But there was one more thing that we kind of got stuck on when we were building the launches controller. And anything that we struggled with when implementing it is definitely something that's worth testing. What was that? Well, it was the way we handle our launch date. Remember, what we pass in as the launch date in the body will get converted into a date object. And the stringified version of that date object is what will be returned in the response. So we should probably be checking the response body that's returned from this request to make sure that all of the appropriate properties are being set. So we could do, this time we're not going to use our supertest assertions. Whenever we check the body, we're going to use our jest assertions. So we'll say expect response.body, and here's where we'll be using some of Jest's assertion API. So in our jestjs.io website, we can go under the API, and then on the left here, under expect, we have a list of all of the different ways that we can expect two values to match. So we've already seen that we can do expect.toBe and pass in a value, which is used to compare primitive values. For example, that a value is 12. But if we want to check that one object contains a certain set of properties, we're going to use a different match function. So let's take a look. We have this .toMatch object function, which sounds like it's doing what we need. It checks that a JavaScript object matches a subset of the properties of another object. What this means for us is that we can say expect response body .toMatch object, passing in a set of properties that we know need to match. So what if we pass in everything that we sent in the request? Let's see what our tests are telling us. We have a failure. The launch date that we passed in was January 4th, 2028, but what we got back was this stringified JavaScript date format. We're going to need to handle the date in a different way. Let's remove the date from our object that we're matching here, and we'll handle the date above. What we're going to do is we'll set this request date constant, which we'll set to the date that we pass in the request. So first, let's move this object out and set it in our describe block above our test case. This way, we'll be able to reuse it in all of our different tests. And we'll be clear what test data our post tests will be making use of. Let's say that we have a constant complete launch data with everything that we need to pass in. That's going to be this object with all of our required properties. And then we'll have another constant, launch data without the date. And we'll set that to the exact same object with the launch date removed. Now in our test case, we can send the complete launch data, and it's data, not date. So let's fix that up here as well. Launch data without date, that's correct. We send the complete launch data, and then we match the launch data without date. To make sure that the date part is working as we expect, we set the request date variable here to complete launch data dot launch date, and we're going to match this in some way with the date that comes back from the response, which will be const response date, and that's the response.body.launch date. So we've extracted the date from our response and from our request. Now we need to make sure that they refer to the same date, even if they're in different formats. We can do this by passing in those values into our date constructor and matching the values of those dates. So we can use the .valueOf function to get the numerical representation of our date, which we can then compare with our to-be matcher, because it's a primitive value. So let's see what this looks like. We'll construct our response date, new date, response body launch date, dot value of. And now to make sure that they're equal, we'll say expect response date to be request date. It reads almost like English. Let's see if Jest likes what we've written. Looks good. Our tests are passing. We can even see the logs of our server are showing that we're making a GET request as well as a POST request with the correct response codes. What about the error cases? Let's complete our launches tests in the next video. I'll see you soon. In the last video, we verified that our launches success case works as we expect. What remains is our two error cases. Testing our validation and error cases is almost more important than testing the success. It's where we find out how our API reacts when things don't go according to plan. So let's jump in. Let's take this request code for our success case, and I'll copy that into our first error case here. When we catch one of the required properties as missing. Let's make our test async. And inside the callback, I'll paste the code to make our launches request. This time, we're passing in an object that's missing one of the required properties. A property like the launch date. So we can actually reuse this launch data without date object, the one we used when we were matching our success case. So we send the launch data, missing our launch date, and we expect to get back a 400 response, because that's a bad request. Now, we should probably validate the body of our response to make sure that we're getting the correct error. The error message should be different between our two test cases here. So what we're going to say is, again, using the just expect function, we expect the response body, and this time we want to match an object exactly. So there's gotta be a matcher function that helps us do this. Let's see. We have our toMatchObject function that matches an object partially, and we also have this toStrictEqual function that checks two objects that must have the same type, as well as structure, including all of their properties. I think we can use this. So we expect the response body to strictly equal this object that comes back in our controller. This one that says error, missing required launch property. So I'll copy that and pass that in to our equality check. Do you think we've done things correctly? Let's see. Our tests have run, and this time we're making 2 post requests, and all of our tests are passing. So far, so good. Let's copy our test over here and use this as a base for our invalid date case. Again, our function needs to be async. And what we'll do is pass in a post request to /launches. And this time we need a new object. We can't just pass in the object without a date. We need to create one that has the launch data with an invalid date. So let's take our complete launch data and change the launch date to be Zoot. That's not a date. And now we'll take this object, and in our test, let's see what response we get when we try to create a new launch. It'll be a 400 response, but this time we won't get back that the required properties are missing, but instead that we have an invalid launch date. So let's set the error correctly. And we should indent our code correctly. Okay, it's time. We've written our 4 tests. Is everything passing? Beautiful. Our server is logging that we're making 4 requests and we're getting 4 check marks in a test run that's taking about half a second. Now, we could test many more different cases, even for our launches endpoints. For example, we could check for our success and upcoming properties in the success case. Those should be set to true. And our flight numbers, again in the response, should increase one by one if we keep adding new launches. We would add those using the exact same functions that we've been using here. The one thing that is different that we may need to add in the future is if we're using a database and we want to mock out the functionality of that database like we talked about earlier. We'll get there. We'll be talking about mocking when doing API tests later in the course as well. For now, I'm confident enough that our code works. Tests are all about giving us the confidence that our code works as expected. If they're helping us with that, our tests are doing their job. That's all for now, and I'll see you in the next one.